Hey class, in this video we're going to be taking a look at what is the best design for a robot. When building a robot for a competition or for class, it's important to consider what the best design is for that particular task. So what is the best design? Well, that's what we're going to take a look at today. So when designing a robot for an in-class competition or a competition, what are some things you should consider? While there's a lot to consider when designing a robot for a competition, there are 4 things that I want to discuss today. The first one we'll discuss is center of gravity, we'll discuss sturdiness, exposure and vulnerability, and lastly, usage. By keeping these 4 things in mind when you design a robot, your robot will be successful. Stability is essential for a robot, and as we take a look at stability, it's important to understand center of gravity. Center of gravity is the average location of the weight of an object. Growing up, I played ice hockey and was always told by my coaches to bend my knees to lower my center of gravity so I wouldn't fall over when I got pushed around by another player. In the same way, skiers have to bend their knees and arch their back to lower their center of gravity. And also, football players, when using a 3-point stance, are changing their center of gravity for an explosive start off the line. So when building a robot or designing a robot, it's important to consider where the center of gravity is for your robot. To figure out where the center of gravity of your robot should be, it's important to discover what the support polygon is for your robot. What is a support polygon? Well, the support polygon is the shape formed by the points where your robot touches the ground. Now, usually the wheels are what touch the ground, and it varies by design, but there's always one support polygon for any stable robot configuration. The robot on the screen has a support polygon that is made by drawing the point of contact for where the wheels touch the ground, and then drawing a box or polygon on where those points connect. That is your support polygon. So now that we know that the center of gravity is the average position of all the weight on the robot, and the support polygon is formed by where the robot's wheels touch the ground, then the robot will be most stable when the center of gravity is centered over the support polygon. So remember, stability is an important consideration when designing a robot. And because robots don't usually stand still, they move around, it's important to take in consideration stability and the center of gravity of the weight of your robot. Take a look at the robot in the diagram. Do you think this robot would be able to climb up a ramp? What would be a better design for this robot that would improve its stability and center of gravity? One idea to improve the design of this robot is to take the 1 kilogram weight and move it so it's above the support polygon of the robot. When designing a robot, especially as part of a team, it's important to be able to clearly communicate ideas. And one of the ways we can clearly communicate ideas is through sketching. Sketching is simply taking your ideas and putting it down on paper. Now, you don't have to be an artist to sketch, but you do have to be able to take your idea and put it down on paper. Some benefits of sketching include helping you communicate your ideas, helping others on your team understand what it is you're trying to say, and help to avoid confusion. Robots are usually complex and have a variety of features. By drawing a sketch of your idea, you help your teammates understand what it is you're trying to explain. Myself, I'm a visual learner, and often when somebody explains something to me, I often say, "Hey, can you draw me a sketch? Can you draw me a picture? Look at the sketches on the screen. What do you think this robot is being designed to do?" Some ways that you can improve a simple sketch is to use label to label some of the parts. You could also add another view, a top view, front view, side view. Another thing you can do is to add a description of what it is you're trying to draw. Lastly, it's important to keep your sketches. You never know when an old sketch might come in handy later to improve your design. Here's another robot design. Do you think this robot would be able to pick up the heavy weight using the claw where it's positioned? What would be a better design for this robot? In class, I would encourage you to draw a better design for this robot using a sketch, using the sketching techniques that we just discussed. One idea to improve the design of this robot is to move the claw back and down so that the center of gravity of the claw and the weight of the robot is over the support polygon. Another design consideration is sturdiness. You've got a lot of fasteners in your kit. It's important to use them. Use them. Robots can fall apart because parts are not tightened, not secure, or move around. It's important to spend the first couple minutes with your robot making sure all the parts are nice and tight, or else your robot will fall apart and malfunction. Take a look at the robot in this diagram. What are some sturdiness flaws that you see? What would be an improvement for the sturdiness of this robot? An easy solution to improve the sturdiness of the robot is to add a couple screws rather than just having one. Another idea is to add a brace to support the arm. This will give the robot more structure, more support, and prevent it from falling apart or breaking. With any design, there's usually more than one correct answer. The next area is exposure and vulnerability. We've talked about how expensive these robots are, so it's important to remember that some of the parts of the robot are fragile and expensive to replace. Can you think of which parts are fragile and expensive to replace? Well, it's important to remember that when you're designing a robot, you have to design it to protect the parts from unwanted contact. Remember how we talked about sports? How do athletes protect their head from unwanted contact? Well, we might not be able to build a helmet for our robot, but we have to make sure that the wires are in the right place. Take a look at this robot design. What are some flaws in this robot? What would be some ways to make this design better? Some possible ideas would be to zip tie the wires together so nobody can get tangled on the wires. Another idea would be take the robot brain or microcontroller and move it more forward towards the center of gravity of the robot, so it's not hanging off the back. Another consideration is usage. And you have to ask yourself, what does your robot have to do and what are you limited by? As we take a look at different VEX robotics competitions, there are some different strategies in how your robot can win the game and get the most points. As your team tries to come up with a design, it's important to think about what your robot has to do and what you're limited by. For the VEX competition, one of your limits is size. Usually VEX robots can only be 18 inches by 18 inches by 18 inches. I've been to competitions where a robot has been off by 1/4 of an inch and couldn't play, so judges are very strict. Other considerations are how many motors you can use, how many batteries you can use, and the weight of the robot. Understanding your limits will help you design a better robot, a robot that will meet the competition task. Years ago, in the VEX Robotics Competition Gateway, the robots had to be able to pick up the round objects and the drums and be able to put them inside these little goals that varied in 3 different sizes. So the challenge was, how do you pick up a round ball? How do you pick up a drum? How do you move it into that area? It was interesting to see the different robots' designs that met that challenge. It's important to know that some robots are multi-purpose, meaning that they have several different uses for one robot. As you consider the current VEX Robotics competition, what are some things that you might be limited by, and what type of robot could you design to meet that competition goals? Ultimately, there's a lot of things to consider when designing a robot. The 4 things that we talked about today were center of gravity, sturdiness, exposure and vulnerability, and usage. We also discussed how a sketch can help you communicate your ideas for the best robot. So again, what is the best design for a robot? Well, the best design for the robot is a robot that does the task it's been designed to do. Thanks for watching.